Have you ever wondered if what you perceive as reality is truly real? This question might seem a bit philosophical, even existential, but it's also deeply scientific. You see, we humans have a limited set of senses, and these senses help us interpret the world around us. We can see the colors of a rainbow, feel the warmth of the sun, and hear the rustle of leaves in the wind. But that's not the whole picture. Our senses are like a narrow window through which we see a tiny slice of the universe. There's a whole world of phenomena out there that we simply can't perceive. Things like ultraviolet light, infrasound, and cosmic rays. In a sense, our reality is a bit like an iceberg, with only a small fraction visible to our senses, while the vast majority remains hidden beneath the surface. And it's not just about what we can't perceive, it's also about how we perceive what we can. Take color, for instance. We see an apple as red because it reflects red light while absorbing other colors. But red isn't a property of the apple, it's a property of the light and our perception of that light. In a world without light, the apple wouldn't be red, it wouldn't be any color at all. This is where things start to get really existential. Question of the reality of matter was famously put forth by Max Planck. He said, "As a man who has devoted his whole life to the most clear-headed science, to the study of matter, I can tell you as a result of my research about the atoms this much. There is no matter as such. All matter originates and exists only by virtue of a force which brings the particles of an atom to vibration and holds this most minute solar system of the atom together." He further explains matter does exist, but the nature of that existence is what is under investigation. Matter is, by definition, that stuff which occupies volume and carries at least some energy as mass. There is sufficient evidence to support the belief that such stuff exists, because if our senses can only perceive a fraction of reality, and our perception of that fraction is influenced by the nature of our senses, then what is reality really? Is it what we perceive, or is it something more, something beyond our perception? This question leads us to the realm of quantum mechanics, a realm where particles can be in two places at once, where they can pop in and out of existence, and where the act of observing can change the observed. So, if our senses can't be entirely trusted, then how do we understand the nature of reality? Well, that's a question for the next scene. Stay tuned as we delve deeper into the world of quantum mechanics and the illusion of reality. As we continue this exploration, consider the following. Why do we think that the way we view reality is right when our senses are limited? Could it be that we are primed for survival on this planet rather than perceiving the full nature of reality? Join us in as we probe these compelling questions. Max Planck, the father of quantum theory, had a unique perspective on the nature of matter. The man who devoted his life to the study of matter, Planck proposed a revolutionary idea. All matter originates and exists only by virtue of a force. This force brings the particles of an atom to vibration and holds this most minute solar system of the atom together. But what is this force? According to Planck, we must assume behind this force is the existence of a conscious and intelligent mind. This mind, he believed, is the matrix of all matter. This idea challenges our conventional understanding of reality. We tend to think of matter as something solid, tangible, something we can touch and feel. But Planck's perspective paints a different picture. It suggests that matter is not merely a physical entity, but the result of a force that is guided by a conscious and intelligent mind. This mind, Planck argues, is the root of all matter, the foundation upon which reality is built. Planck's perspective adds another layer of complexity to our understanding of reality. It suggests that reality is not just a physical construct, but a mental one as well. It's a thought-provoking idea, one that invites us to reconsider our perception of the world around us. As we delve deeper into the realm of quantum mechanics, keep Planck's perspective in mind. It serves as a reminder that reality is not always what it seems, that beneath the surface of the tangible world lies a realm of forces and energies, a realm where the line between the physical and the mental becomes blurred. Stay tuned as we continue this exploration into the nature of reality, into the world of quantum mechanics and the illusion of reality. Enter the realm of quantum mechanics where the rules of the universe as we know it are turned on their head. To understand the birth of quantum mechanics, let's time travel back to the early 20th century, where a German physicist named Max Planck was grappling with a puzzle. The puzzle was about the radiation of energy from heated objects, something that classical physics couldn't quite explain. Planck, in an act of desperation, proposed a radical idea. He suggested that energy wasn't a continuous stream, but rather it was composed of tiny, discrete packets. He called these packets quanta. Planck's idea was revolutionary. Until then, we believed that energy was like a smooth flowing river. But Planck suggested it was more like a staircase, where you can only move up or down in specific steps. This concept that energy is quantized was the first step into the quantum world. But what does quantized energy mean for us? Well, imagine you're trying to heat up a room. According to classical physics, you could increase the heat bit by bit like turning a dial. But in the quantum world, it's more like pressing a button that only has specific settings. You can't choose any temperature you want, only the ones allowed by the quanta. Planck's bold idea paved the way for quantum mechanics. It revolutionized our understanding of the microscopic universe, of atoms and particles, and the forces that bind them. It challenged our perception of reality, of what we can see and touch. It's a bit like realizing that the solid table in front of you isn't really solid at all. It's mostly empty space, filled with tiny particles zipping around at incredible speeds. That's the quantum world for you. Strange, counterintuitive, but undeniably real. Quantum mechanics then provides a new lens through which to examine the nature of reality. One experiment in particular stunned the world of physics, the Double-Slit Experiment. To grasp this mind-bending experiment, let's break it down into bite-sized pieces. Imagine a wall with two slits, and behind it, another wall where we can record the impact of particles. Now, if we shoot a stream of marbles one at a time towards the slits, we'd expect to see two clusters of marks behind each slit. Makes sense, right? That's how particles should behave. But what if we replace those marbles with light, which we know can behave like a particle, a photon? Here, things start to get a little strange. Instead of just two clusters of marks, we see an interference pattern, with alternating light and dark bands spread across the wall. This pattern is a telltale sign of waves, like the ripples created when two pebbles are dropped into a pond. But how can light, shot one photon at a time, create an interference pattern? This means each photon isn't just going through one slit or the other, but somehow through both slits at the same time and interfering with itself. This is the concept of superposition, where particles exist in multiple states at once. Here's where things get even weirder. If we decide to peek and see which slit the photon goes through, the interference pattern disappears. It's as if the photon knows it's being watched and decides to behave like a regular particle again. This is called the observer effect, and it's one of the most baffling aspects of quantum mechanics. So what's the takeaway? Particles can behave as both particles and waves, and their behavior can change when observed. This isn't just true for light. Electrons, atoms, and even some molecules show the same dual behavior. The Double-Slit Experiment reveals the truly strange and counterintuitive nature of quantum mechanics. And it's this experiment that continues to challenge our understanding of the very nature of reality. But what does this all signify for our comprehension of reality? Quantum mechanics isn't merely a catalog of rules applying to minuscule particles. It serves to radically reshape our perception of our surroundings. It confronts some of the core principles on which we've based our grasp of reality. To begin with, let's explore the mathematical universe theory, a profound concept supported by Fourier mathematics. In contrast to classical mechanics, which predicates that an object exists at a single place in time, this theory postulates that our universe is a giant mathematical object. It suggests that every event, every particle in the universe, is a point in a mathematical structure. This mathematical structure can theoretically be decoded using Fourier mathematics, which forms the foundation of quantum mechanics. Another fascinating perspective is that of Walter Russell, who proposed that reality is essentially frozen light. According to Russell, the entirety of our observable reality is composed of light in different states of motion or frozen at different rates. These views challenge our traditional understanding of reality as they delve into the fundamental fabric of the universe, hinting that the essence of reality might be abstract, mathematical, and fundamentally composed of light. These interpretations are far from being merely philosophical musings. They establish the foundation for advancements such as quantum computing, teleportation, and the potential of a unified theory of physics. These perspectives encourage us to reevaluate our assumptions, embrace ambiguity, and persist in pushing the boundaries of our understanding. Quantum mechanics thus challenges our customary interpretations of reality and compels us to rethink what we believe we know. So the next time you gaze at the stars, bear in mind, the universe may be more peculiar than we could ever fathom. So, where does this leave us in our understanding of the universe? Let's take a moment to reflect on the incredible journey we've embarked upon today. We've delved into the heart of reality and found it to be far stranger and more wonderful than we ever could have imagined. We started off in the realm of the everyday, where our senses give us a view of the world that seems solid and predictable. But as we've learned, this is only part of the story. Our senses, as remarkable as they are, can only perceive a tiny fraction of the universe. Most of what's out there remains hidden from our view. Next, we ventured into the birth of quantum mechanics, a revolutionary theory that emerged in the early 20th century. It was Max Planck who first suggested that energy is not continuous, but comes in discrete packets called quanta. This simple idea turned our understanding of the universe upside down and paved the way for a whole new way of seeing the world. Then we explored the Double-Slit Experiment, a mind-bending demonstration of quantum weirdness. When particles of light or matter pass through two slits, they behave not as individual particles, but as waves that interfere with each other. This suggests that reality is not made of solid particles, but of waves of potentiality. Finally, we considered the implications of quantum mechanics. This theory challenges our preconceptions about reality and forces us to question our deepest beliefs about the nature of the universe. It tells us that at its core, the universe is not made of matter, but of waves of potentiality. In the end, the quest to understand reality is a journey that takes us into the heart of the strange and wonderful world of quantum mechanics. The universe is much more complex and fascinating than we ever could have imagined, and there's still so much more to discover. So let's keep exploring, questioning, and marveling at the wonders of the quantum world. Let's consider some additional perspectives on the nature of reality. As we've just seen, the quantum world is full of surprises and paradoxes that challenge our everyday experience. But there are other ways of thinking about reality that can also broaden our horizons. Firstly, let's consider the views of Walter Russell, a polymath who proposed a radically different understanding of matter. He suggested that matter is simply frozen light, a concept that Nikola Tesla, the famous inventor, admired for its advanced thinking. According to Russell, the universe is not made up of separate particles, but is a continuous field of light. This view, while not mainstream, resonates with some aspects of quantum theory and provides a fascinating alternative perspective on the nature of reality. Next, let's delve into Schrödinger's famous thought experiment, which is often misunderstood. Schrödinger proposed a scenario where a cat in a box could be both alive and dead at the same time, depending on the state of a radioactive atom. This was not meant to suggest that cats can actually be in two states at once, but rather to highlight the absurdity of applying quantum mechanics to everyday objects. Yet, this thought experiment has become a central part of our cultural understanding of quantum mechanics and continues to spark debate and discussion. These perspectives further enrich our understanding of the quantum world and the nature of reality. They remind us that reality is not just what we can see and touch, but is a complex and mysterious realm full of potential and wonder. As we continue to explore and question, let's remember to keep an open mind and to embrace the richness and diversity of our universe. Before we wrap up, here's a friendly reminder. If you've enjoyed this enlightening journey through the quantum world and the various perspectives on reality, don't forget to like and subscribe. Your support allows us to continue providing fascinating insights into the mysteries of the universe. And as we depart from this quantum exploration, let's remember a quote from one of the most innovative minds of the 20th century, Nikola Tesla. He said, "If you wish to understand the universe, think of energy, frequency, and vibration." This quote beautifully encapsulates the essence of the quantum world and serves as a reminder that reality is far more complex and intriguing than our everyday experiences suggest. So keep your mind open, continue questioning, and never stop exploring the wonders of the universe. Thank you for watching, and until next time, keep exploring the wonders of the quantum world and beyond.